Welcome to the second part now of the Unit 3 review. I have question number 9. Suppose there is a 28.5% probability that a randomly selected person aged 20 years or older is a jogger. In addition, there is a 22.7% probability that a randomly selected person aged 20 years or older is female, and given that he or she jogs. What is the probability that a randomly selected person aged 20 years or older is female and jogs? And then, would it be unusual to randomly select a person aged 20 years or older who is female and jogs? So, we were told that for this, we want the probability person is aged 20 years or older is female and jogs. So this would be the probability of being female and jogging. So, in order for us to do this, we are going to take the value that of the probability of being female times the probability of jogging, given that the person being, right, this would be the probability of being, I wrote this wrong, a jogger, times the probability of being female given that he or she jogs. There we go. This will be 0.285 times 0.227. Multiply those together, this is 0.065. Which is greater than 5%. Right? 6.5% greater than 5%. It is not unusual. All right, moving on. Number 10, we want the value of 6 factorial. Right? This should just be 6 times 5 times 4 times 3 times 2 times 1. This would give us 720. 5 choose 4, this is 5 factorial, divided by 4 factorial times 1 factorial from 5 minus 4. Most of this cancels and we're just left with a 5. 5p2, so the permutation, 5 factorial divided by 5 minus 2 factorial, or 3 factorial. We're just left with 5 times 4, which is 20. Question number 11. I have outside a home, there's an 8-key keypad numbered 1 through 8. The correct 4-digit code will open the garage door. The numbers can be repeated in the code. We want to know how many codes are possible. Well, there are 8 keys, and there's 4 digits. So this would be 8 to the 4th power, which is 4,096. The probability of entering the correct code on the first try, assuming the owner does not remember the code. So this would be on the first try. There's only one way to get it right on the first try, and that's by getting it right. And there are a total of 4,096 total codes. This, as a decimal, is 0.000244. A very small number indeed, so don't forget those codes. Question number 12. I have the grade appeal process at a university requires that a jury be structured by selecting 5 individuals randomly from a pool of 7 students, 11 faculty, and with the probability of choosing all students. So just as we did in class, this is going to be, we have a total of 7 students to choose from. We want to choose 5 of them. We have a total of 11 faculty to choose from. We want none of them. We have a total of 18 individuals to choose from, and we want 5 of those individuals. If you put this into a calculator, being mindful of the multiplication and division, this is about 0.002. Again, this should be the smallest number that we have. The probability of all faculty. We have 7 students. We want to choose none of them. We have 11 faculty. We want to choose 5 of them. And there's a total of 18 individuals. We want to choose 5 of them. Passing this into a calculator gives us a slightly bigger decimal, 0.054. And then finally, the last one, this is the probability of 3 students and 2 faculty. So 7 students, we want to choose 3 of them. There are 11 faculty, we want to choose 2 of them. And there are still 18 people, we want to choose 5 of them. Multiplying and dividing, this is the biggest value, 0.225. Okay, so this was that second part of this Unit 3 review. Good luck on the test. Let me know if you have any questions or concerns. Thank you.